Hi learners! In today's video, you will learn what a rigid transformation is, the different types of rigid transformations, and what happens to the geometric figures before and after a rigid transformation takes place. You will also learn how to write congruent statements for geometric figures that has undergone rigid transformations. Finally, we will analyze and answer sample problems to let you experience how these are done so that you will be able to successfully solve math problems similar to this in the future. If your lesson is on rigid transformations, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. Let us start by describing what a rigid transformation is. A rigid transformation is a process of moving any object or any two-dimensional geometric figure in space or on a coordinate plane. The three basic rigid transformations are reflection, rotation, and translation. But rigid transformation can also be a combination of two or all of these three. So, what is a translation? Basically, a translation is a slide. Translation slides or pushes an object like this. Look at the object after the push was applied. Is there a change in the size and shape of the chair after it is pushed? No. So in translation, the size and shape of the object do not change. What is changed is its location. How about reflection? Oh, reflection is a flip. Reflection flips an object over an imaginary line. Look at the object after the flip. Is there a change in the size and shape of the object after it is flipped? No, its size and shape are the same. So the size and shape of the object are not changed. What are changed are its location and orientation after a single flip. The third one is rotation. Rotation is a turn. A rotation turns an object about a point. Look at the object this time. Is there a change in the size and shape of the object after it is rotated? Again, no. The size and shape of the object are the same. At times, a single rotation could result on its position and or its orientation being changed depending on the size of the angle of rotation that takes place. Learners, you have to remember this. In any rigid transformation, the object retains its size and shape after the transformation. We can illustrate the process with this diagram. Look at the diagram, learners. Before the transformation, there is the original object or figure. We call this the pre-image. After the transformation, there is the resulting object or figure. We call this the image. In geometry, these objects are oftentimes represented by two-dimensional figures like triangles, rectangles, and other polygons. These figures are given names by identifying the vertices, the corners, using the uppercase letter of the English alphabet. Here, the triangle has its vertices, corners, labeled N, F, and H. We now call the triangle NFH. If triangle NFH is translated, the process could be illustrated this way. You notice that the pre-image and the image use the same set of letters for their names. To differentiate the pre-image from the image, if they are named this way, the image is denoted by the prime notation, like what we have in the illustration. Remember that after a rigid transformation, the size and shape of the image do not change. The side lengths or distance and the angles are preserved. We say that the pre-image and the image are congruent. This is the symbol for congruence. So for triangle NFH that undergoes a translation to form triangle N prime F prime H prime, we write the congruent statement this way. We read it as triangle NFH is congruent to triangle N prime F prime H prime. So we can say that if two figures are congruent, there must be a rigid transformation that took one figure onto the other, right? Now, how do we know if the two figures are congruent? First, you have to check if the corresponding parts match up. How do we do this? Put a figure on top of the other. If it fits perfectly onto the other figure, the matching sides and angles are the corresponding parts of the two figures. When the sides and the angles match up, the corresponding parts of the two figures are congruent. This could be points, sides, or angles. And when the corresponding parts are congruent, the figures are congruent. Conversely, congruent figures are figures having corresponding sides that are congruent and corresponding angles that are congruent. In ordinary language, we say that angles are congruent when they have the same measure, and sides are congruent when they have the same length or distance. Let us look at this sample problem to check our understanding of the concepts that we have just learned. Sample problem 1, here is the problem. A geometry student transformed triangle NDC to make triangle N prime, D prime, C prime. Are the triangles congruent? Why or why not? Select the correct answer and justification. A figure is given here. Here are the options. A, no, they are not congruent. Triangle NDC was translated to form triangle N prime, D prime, C prime. Option B, yes, they are congruent. Triangle NDC was translated to form triangle N prime, D prime, C prime. Option C, no, they are not congruent. Triangle NDC was reflected to form triangle N prime, D prime, C prime. Option D, yes, they are congruent. Triangle NDC was reflected to form triangle N prime, D prime, C prime. Okay, so we start by reading the whole problem, and we may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? We are asked if the triangles are congruent or not, and we are to justify our answer. What are given here? We are informed that the students transformed the figure. Look at our options. They might give you an idea of what you're going to do to successfully answer the problem. After looking at the options, were you able to get an idea of what type of transformation must have taken place here? Yes, the transformation could be reflection or translation. Okay, what do we know about these types of transformation? Right, that the pre-image and the image are congruent. Okay, so we are almost there. At this point, we have already narrowed down our choices. Options A and C are now out. Did you understand why, learners? So our answer choice could either be a B or a D. To decide which one is the answer, we have to examine the transformation that took place and determine what type of transformation was applied. Is it a reflection or a translation? How do we verify this? Let us examine the given illustration. What do you think happened here? Was there a reflection or a translation that took place? Recall how we described a reflection. What about a translation? Okay, look at the illustration carefully. Which do you think took place here? You are correct. Triangle NDC was pushed to the right. To be exact, it was pushed 3 units to the right. So a translation took place. So what is the answer, learners? You are correct. It is option B. Yes, they are congruent. Triangle NDC was translated to form triangle N prime, D prime, C prime. How was it, learners? It was easy, right? Okay, we will use the result we got in sample problem 1 to discuss these important concepts about congruent figures. Because the 2 triangles in the previous examples are congruent, we can write this congruent statement about them. We read this as triangle NDC is congruent to triangle N prime, D prime, C prime. Since the triangles are congruent, their corresponding sides and corresponding angles must be congruent, right? We can therefore write the following congruent statements for their corresponding sides. We read this as side ND is congruent to side N prime, D prime. Take a moment and look at the congruent statements that we have here so far. Side ND are the first 2 letters of the triangle NDC, the pre-image. And side N prime D prime are the first 2 letters of triangle N prime D prime C prime, the image. Can you tell us now the other pair of corresponding sides that are congruent? Yes, side DC and side D prime C prime are corresponding sides and are congruent. D and C are the second and the third letter of the pre-image, and D prime C prime are likewise the second and the third letters of the image. So we can write, in like manner, side NC and side N prime C prime are corresponding sides and are therefore congruent. N being the first and C the last letter of the pre-image, and N prime being the first and C prime the last letter of the image. So we can also write this. It is the same thing for the angles. First letter of the pre-image corresponds to the first letter of the image. The second letter to the second letter, and so on. So angle N and angle N prime are corresponding angles and are congruent. Hence, we can write this congruent statement. Angle D and angle D prime are corresponding angles and are congruent. We can therefore write this congruent statement for the 2 angles. Lastly, angle C and angle C prime are corresponding angles as well and are congruent. Hence, these congruent statements can be written. The same labeling convention applies to all congruent polygons, whether they have 4, 5, or more sides. For 4-sided polygons that are congruent, we could write a congruent statement like this. In the same way, the order of the vertex letters tells us which angle is congruent to which, and which side is congruent to which. Okay, learners, were you able to get the pattern here? Can you now confidently identify corresponding parts of 2 congruent figures and correctly identify congruent statement for corresponding parts of 2 congruent figures? And can you now write congruent statements of 2 congruent figures and their corresponding parts? Let us go to our next sample problem and see how we can apply these learnings. Here is the problem. Quadrilateral RJLH is rotated to form quadrilateral CMAN. Which statement must be true? Option A, side RJ is congruent to side MA. Option B, side JH is congruent to side CA. Option C, angle L is congruent to angle A. Option D, angle R is congruent to angle N. As usual, we start by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? Okay, so we are to determine which statement is true. Is it A, B, C, or D based on what is given? What is given? We are given that quadrilateral RJLH is rotated to form quadrilateral CMAN. Can you tell us what the given information implies? You are right. The given information implies that the two figures, the preimage quadrilateral RJLH is congruent to its image quadrilateral CMAN, since a rigid transformation, which is a rotation, took place. Did everyone get this? So we can therefore write this. Quadrilateral RJLH is congruent to quadrilateral CMAN. From the congruent statement, we can identify corresponding parts that are congruent, right? Like the interior angle at vertex R corresponds to the interior angle at vertex C, J to M, and so on. Same thing with the sides. Side RJ corresponds to side CM, side JL to side MA, and so on. Let us examine the options and find the correct answer. Option A, segment RJ is congruent to segment MA. Let us examine the order of the letters in both the preimage and the image. R and J are the first and the second on the preimage. M and A are the second and the third. So no, not a true statement. The order of the letters is not the same. Option B, segment JH is congruent to segment CA. Where are they located in the preimage and the image? J and H are second and fourth in the preimage, while C and A are first and third in the image. Again, no, not a true statement. The order of the letters is not the same. Option C, angle L, is congruent to angle A. L is third in preimage and A is third in the image. So yes, the statement is true. The order of the letters in both preimage and the image is the same. Option D, angle R is congruent to angle N. R is first in the preimage, while N is fourth in the image. So no, not a correct statement. The order of the letters is not the same. So the answer is option C. Angle L is congruent to angle A. Wow, that was easy. Let us go to sample problem 3. Here's the problem. When the right triangle MHN is reflected over line T, its image, triangle AHN, is created as shown below. Which statement justifies why side AN is congruent to side MN? A, Right angles remain congruent under reflection. B. Points on the line of reflection remain invariant. C. Orientation is preserved under reflection. D. Distance is preserved under reflection. We begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? Right, we are going to look for the statement that would justify why side AN is congruent to side MN. What are given? We're given that right triangle MHM is reflected over line T, creating triangle AHN. And we are given a figure. Now, we will take a closer look at the given information and find out if there's something in that given that will help us find what we are looking for. Let's go. Okay, what do you think is the important word here on the given, the first sentence, that might guide us on where to start with our analysis? Great, the word is reflected. The problem states that the right triangle is reflected. What does it imply? You are correct that the two triangles, the pre-image and the image, are congruent. Now we know that when two triangles are congruent, the corresponding parts are congruent, right? Again, what part of the triangle are in this congruent statement? Do you see this in the drawing? Okay, so they are the sides, the corresponding sides. Remember that. Remember that we are to find the statement that would justify why these sides, side AM and side MN, are congruent. Okay, let us look at the options. We will start with option A. Right angles remain congruent under reflection. What can you say about option A? Would this statement justify why side AM is congruent to side MN? Of course not. Look at the illustration. What is highlighted? The sides. Option A is about the right angles. We are to justify why the sides are congruent, not the angles, okay? Let us look at option B. Points on the line of reflection remain invariant. Would option B justify why side AN is congruent to side MN? Option B is about the points on the line of reflection, which is not our concern at the moment. This would not justify why side AN and side MN are congruent. Look at option C. Orientation is preserved under reflection. Option C would not support or justify why side AN is congruent to side MN. Not an answer for two reasons. First, the statement is false because orientation is not preserved under reflection. Second, we are not after the orientation of the figure. We're after the statement that would justify why side AN is congruent to side MN. Let us look at option D. Distance is preserved under reflection. Distance here refers to the length of the side. Let us recall this statement. Thus, option D, distance is preserved under reflection, is the correct answer. The statement justifies why side AN is congruent to side MN. So our answer is D. There you are, learners. Hopefully, you acquire a lot of learnings in today's video. Okay, let us then summarize what we have learned in today's video. We have learned that, first, rigid transformation is a process of moving any two-dimensional geometric figure in space or on a coordinate plane. The three types of rigid transformations are translation, reflection, and rotation. Second, translation is a slide. Translation slides or pushes an object. Third, reflection is a flip. Reflection flips an object over an imaginary line. Fourth, rotation is a turn. A rotation turns an object about a point. Fifth, after a rigid transformation, such as translation, reflection, and rotation, the size and shape of the image do not change. The side lengths or distance and the angles are preserved. We say that the pre-image and the image are congruent. Sixth, congruent figures are figures having corresponding sides that are congruent and corresponding angles that are congruent. Seventh, angles are congruent when they have the same measure, and sides are congruent when they have the same length or distance. Eighth, if you are given that two figures are congruent, but no illustration comes with it, the corresponding parts can be identified through their names. The order on how the letters on their names appear will tell you which part correspond each other. The first letter on the pre-image corresponds to the first letter on the image, the second to the second, and so on. Ninth, when solving a problem, you must read it and may read it several times to know what you're looking for, what information are given, and to figure out how the information can help solve the problem. 10. When a figure is given, make use of it. It is there to help you in analyzing the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn